Okay, let's start the link. So yesterday, the last chapter we are discussing file handling. So yesterday I was in a fast mode and skipping so many things. So that's why I want to take my time and understand this file handling. So let let us go through this file handling once again. So what is file handling? So it is nothing but process of creating, opening, reading, writing, modifying, closing files using C. So creating, opening a file, create a new file, opening a file, now reading it or writing, modifying it inside. So then closing the files. So normally variable store data temporarily in RAM. So this value X will be taking will be stored in temporarily RAM. So a file allows the data to be stored permanently on secondary storage such as SSD or hard disk. So files will be in SSD or the secondary storage. So secondary storage is the non-volatile memory. So even if your computer fails, like the power due to power fails, so the computer will be shut down, right? So the secondary memory will not be lost, but inside whatever we inside the RAM, it will be lost. So that is so that is the secondary storage definition. So file is always been the secondary storage. So C program file handling functions we have. So file and secondary storage, write data, read data, append data, modify data. So why do we need files? Suppose you write int marks is equal to 95. Variable marks exist only. The variable marks exist only while the program is running. That is correct. So after program terminates, marks is gone because this stores in the RAM. This is the volatile memory. But if you store 95 in a file, so this file will be in SSD or hard disk. So data remains even after the program terminates. So files provide persistent storage for program data. Lasting a longer refusing to give up. So let's say difference between files and variables. So it is in memory and it is in secondary storage. Temporary. A lifetime is when the program ends. So persistent. So exists during program execution. It also exists after the program execution. Limited by available memory, can store much larger amounts of data. So greater than RAM, you can say. So data disappears when program ends. So data remains after program ends. So types of files in C. So there are two files, text files and binary files. So text files store data in a form that can generally be interpreted as characters. Generally, so when used generally, that means there will be some exceptions also. For example, follow 195.5. A text editor can normally display its contents. Yeah, so human readable formatting includes examples students.txt, data CSV, notes.txt. So binary form stores data as bytes without requiring to be represented as human readable text. So for example, an int may occupy 4 bytes in memory. So its binary representation can be written directly to a binary file. So storing large amounts of structured data, preserving binary representations, efficiency is important. Example students.dat image.bmp uh, data.bin. So structured data preserving binary representation. Uh, plain text international data can be plain text or binary code. So configuration. So let us ask this. So it is telling about how the data is represented, but it's not simple strings and numbers it is telling it. And again, it is telling binary can contain number structures and characters. because ASCII character and is a text representation. If you open in the file and the directory, you can see 100, 400 in binary form. Okay, we are not converting the numbering to characters. Instead, the bytes represent the end objects. So, for example, would be suppose 0, 0, 0. So, hexadecimal 64 is 100. Okay, so the file does not contain the character. So, that is the binary representation. So, the most important distinction. So, the way represented and stored in the field. So, take example. So, this is a binary file. So, now if we write a binary file, you may see something like d dot dot in meaningless error that because it is trying to interpret arbitrary text. So, what does structured data mean? That's it. That's it. Here it can show. Let's ask. Now let us see. You can show right. It's showing D. Let me go to that fifth point. Binary files. Sorry, the 4.2 binary files. So, it's about how the data is represented in file. It's not only strings and numbers. So this is what that means. Numbers and numbers also will be there, but it represents something other. What we read in human form, it will be larger. It will be different. So you can say like data is bytes in binary and general interpreted as characters. So, so examples for binary files are dot dot bin, dot dat, and dot vim are given here. Where it is okay, here you can see dot bin, dot bmp, and dot dat. Here it given text in CSV and other formats, etc. So now let us see the code we have. Got the clarity here. So what does the structured data mean? Structured data means data that consists of multiple pieces of information arranged according to some defined structure. Uh, so it is a defined structure will be there, and these pieces are in organized. So you can say like an example. So this is structured data, and if you call an variable with this student structure, then you will have this three. So this is called the structured data. It is organized. You can write the structured data into not only a binary but text form. It is how you want to represent. If you want to read the file again, you have to represent in human read. If you want to only the purpose is it is to be used by some computer or another program, then you can write in binary. The file could contain 195. The data is character representing numbers. Binary representation. The bytes may look meaningless when viewed as text. So a text file is whose contents are sequence of characters to an applicable character encoding. So generally we'll say UTF dash 088 encoding character encoding. So there is nothing but sequence of character. You can say generally we have to use generally word. So what exactly is binary file? So binary file is then generally a file whose contents are treated as arbitrary bytes rather than represented as human readable. So binary we can see object representations of int and turn it into byte and then write type. So that's all. Nothing to look that much into deep here. So here this point means you open a file and if you say C and you can't judge it's a text file. So it can be like bytes are uh, converted uh, into text form and it gives C. So the real meaning of C is not C here. It can be text. Some binary representation is represented in C when we want to say binary bit. So that's what here they are telling. So the file type. So the fifth one, C provides a type called file. So it is used for files. So it is declared in stdio.h. So file is general access to a file pointer. So we have to write file star fp. Yeah, now it is giving error. You can see. So the file functions all returns a pointer address pointing so that we can catch the address using pointers. So that's why it should be a pointer, file pointer you can say. So now let's see why do we use file pointer. So fp file star fp. So fp does not contain the enter file. Instead, it uses a C library to refer to an open stream associated with the file. Conceptually, disk file, operating system, C library system, file object, and just give me a minute. I am back. I'm back. Thanks. Now let us see. So instead, now it does not find edited under file. So refer to an open stream associated with the file. So what is mean? This operating system, C library, file object, and we'll have file object here. So this pointer points to this file object. So we use FP with functions such as fopen, fprintf, fscanf, fgetc, fcc, fread, fwrite, fclose. So let's ask, so what is the meaning of this open string? So let's ask this question. So what is open string means? Tell as much clarity as possible. as crafty as possible. I mean, explain the topic. Before that, let us see this one. Per 100 byte is given 6400. Okay, it's a 4 byte representation. Integer is 4 byte representation. So 32 bits. So, so 100. So first bit contains the value of 100. So while the remaining bits are 0. So 32 bits. Then I would write 0100. So the byte order would be 00064. So big Indian system, I think we'll see in uh, digital logic or computer organization. So for now, we'll think like this. Let us now see what is OpenStream means. So stream is not an literal another thing than what it is. First, what is a stream? A stream is an abstraction that represents a flow of data between a person and some action towards a uh, destination. So it is like a mediator. So a flow of abstraction that represents a flow between a person and some external source and destination. So, for example, program keyboard, program string, program file. We represent this data flows using string. So, why does use the word stream? Imagine water flowing through a pipe. Okay, so you don't know, need to know every detail of how the water moves inside the pipe. So, you simply think there is a flow of water through a pipe. So, C standard IO library gives you a stream interface. So, a file in itself is not the stream. So that is this distinction is extremely important. Suppose you have a data.txt, it will be stored in hard disk secondary storage. When your program wants to work with it, you open it file star is equal to fopen data.txt. So now there is a C stream associated with that file. So it's like a between disk and IO. Again, it access through operating system. So when we say open stream associated with the file, it means C has established a stream through which your program can communicate with that file. Stream through which you can, okay. Like a connecting, okay. Uh, File object information maintained by C library stream associated with the data.txt file. So file object stream maintains information needed by the C library to perform IO. So for example, conceptually it may involve things like connection to underlying file, current stream position, buffering information, EOF indicator, error indicator, streamer mode. So let's not go into that much deep. We'll be doing whatever we let's remember for now. Stream is like a between our between flow of program and destination, right? Some external source or destination. So a flow of data between your program and some external source of destination. Low level detail of the device of file. So the stream interface. Okay. Now let us continue. So we understood stream. So, so it will be pointing to a file object which contains the connection, buffer storage, and EOF indicator. So related data about the file so that we can access the data inside it and metadata also. So F4 printf, fscanf, fgetc, fputc, fread, fwrite, fclose. So let's see the functions of C. So if you want to do something in file, then you have to open it, right? So the most important function for opening a file is fopen. So file star fopen. So this is the syntax. So file star fopen constant. So it gives a pointer, file pointer. It presents a file pointer. Star file name. You have to give file name and the mode. So this file is only to be read or only to be write, or it can be read plus write or write plus read, or only append or append plus write. So now let us see. So data.txt or so file name, and this is the opening mode. So it successfully opens returns a file star. If it fails, then it will give null. So we have to use write this. So now we will learn about the file opening modes. Now we will learn about opening modes. So this is a read mode. This is the write mode. Only read can happen here. Only write can happen here. In the file, we can't read also on the terminal. So a append is just inserting existing data will be there. You have to insert in it. R plus means read plus write. So you can read it and write the file also. So W plus means write plus read. So A plus means append plus read. So there are also binary variants. So this is for binary files. So same we will see R mode. So meaning opening an existing file for reading. So in R, if there is no file already exists, then it doesn't open. It gives an null. So you have to catch it null and write cannot open file. So W mode, if it is not, it is for writing. If the file doesn't exist, it creates and writes the data. But if the file contains existing, then yeah, the old data will be removed even if you don't write any data also. So this is extremely important. Just for calling with fopen w, it will truncate this data. So A mode means appending. So it is also if file doesn't exist, it is created. No data is written at the end. That will not replace the existing data. It will write at the end of the data. You can see it. Hello is there. Now if we do a printf, hello world will be going. So existing data is not erased. So R plus mode. It consists of both opening and existing for reading and writing. So R plus. So R is the main here. So in R, if file is not existed, it will give null, right? So file must exist. Existing contents are preserved. The initial file position is at the beginning. So when you write to something, it will replacing that data. Okay, so existing data may change. It will not truncate it. Suppose let's say if you give this one world into the hello, so it will replace the letter by letter. So the first H will be gone with W, E will be gone with O, R will be gone with L, and like this. So it will be replacing the old existing data. So W plus, so it is also reading and writing, but W will give you a write. So if the file doesn't exist, it will only create. If file exists, it truncates the whole data. So A plus mode, so A plus means append plus reading. So if file doesn't create, it creates it. And if you want to read the file, you can read. So now let's see the most important file modes table here. So if I say R, you can read it, but you can't write it. Creates if the absent is not. If file is not there, it doesn't create it, and erases existing contents. You cannot do because no write is performed. And the W, we can't read it. Yes, we can't read. We can only write. We can't read the file data and show it in our terminal. So what that is what it means. You can do the write. Creates if file is absent, not there, it will create and it erases the existing content. So append. It doesn't. We can't read the data. Only we can write at the end of the file, and then creates if it is also same like write, and but it does not erase existing content. So R plus we can read write, but if file is not there, it can't create a new file, and I can't erase the existing content. So it, on just opening R plus, writing a open R plus, then it will not erase the old content. But if you write W plus, it will erase the existing content. So that is the difference. So read, write, create if absent, and erase the existing content. So A plus, so read, write, and create if absent, but it will not erase existing content. So easy way to remember: read, write, append, add the other operation. So read plus read, write plus read, and append plus read. Okay, so let's see text and binary modes. So it is also same. Only B means it represents binary. So that is a binary. So it means RB. So if you write here R only, then it will be reading this file in text file form. So the existing data will be uh, represented whatever the encoding available at the R. So let's see an example here. carry out to W. Let's open this one. So it gave D same. Let us ask this question to ChatGPT only. So where it is, it is point number 16. So let us see what it gives. So it will be taking as the text mode. So the practical reference depends on operating system. So text and binary systems are yeah, the translation may go wrong even if not for read, but if when we write, it will be thinking as a some text and it will be throwing into bytes, but it does not translate properly. So let us ask that one. Yeah, it may go wrong. So, so in Linux there is no practical difference, but on systems where text and the binary modes differ, notably Windows. Okay. So text mode can perform character translation that can change the bytes being written or read which is undecisional for a arbitrary binary data. For example, index is will unread, and if you wrote this here, upright and use WB, I want binary, this will be read as binary, rather than applying text transform using made overlay perform, but it is not the correct portable size when you intel binary. So remember this. So it can go wrong on system where text mode performs translation. Okay. So that's what I understood. So there is no difference, but systems may go wrong. So let's use what it is recommended. Okay. Let's ask an example. So this is a pen we use the W mode. That could see character we are putting into the file. So A slash and B. So we wrote like exactly A slash and B. So we made this expect the file 41 0 A 42 because A is 41 extra and 0 is extra and 42 extra. Extra is no, but W on mode. So slash and into Windows line ending sequence. So therefore the bytes equivalent to the file will be 0D. What is slash R? Comes from old type writing machine. When I later reached the end of the line, they pushed a lever to return metal carriage, so back to left side of the paper. So paper is like that, will be pushing into the starting position. Let's see this example. Yeah, so R it pushed here, and it replaced this Ritchie L with TJ. So Windows text mode can translate into slash or slashing. So therefore the bytes written to files can be 0 to 0. So 4 bytes are stored even through the program separate 3 characters. Okay. So binary file can be corrupted. Implementation may transfer text characters. Then it is not appropriate. Okay. There's just flash and how it is being used in different environments. That's what we saw. That's what it means. Anyway, let us go back to the point. Where are we? Yeah. We saw what will happen file to bin if we for a binary file if we don't use binary mode. So it depends upon systems, but Linux it is not good. But the problem comes when there the text mode is translated uh, into something that operating systems can understand. So in that the binary corruptions will happen. So closing a file. So after finishing with the file, you have to close the file. So it is integer. Close after same. So it returns integer and open returns file pointer. So why closing the file? So digital resource associated with the stream ensures the buffer output is handled appropriately and ensure use of that stream. So when you close the file, so all the resources can be allocated to some other program. So ensures buffer output is handled properly. So let's see what does it mean by buffered output. Ensure use of the string. So the connection between that pointer and our object will be closed, so the resources can be used. So let's ask what does it mean by buffered output. So here So what does it mean? So buffered output means that your program writes data to a file. So the data may temporarily stay in a memory area called a buffer. So buffer output means when you C program writes data to a file, the data may temporarily stay in memory area called a buffer. So it's like a bridge between the original files and uh, our program. So what will be writing, it will go into buffer and then it will be going into the file of device. Program writes file or write B writes C, so that requires many separate interactions with the operating system or device. So doing this repeatedly can be insufficient. Okay. So with the buffer, the C library maintain a buffer in memory, for example. So your program does the library may put A, B, C into its buffer first. It doesn't necessarily send each character to underlying file immediately. It does this so before interacting with the underlying system. For every tiny piece of data can be expensive. Uh, so it is like planning everything into one last transfer. So it is like IO sufficient. So the OS doesn't only run this program, right? It will be having so much other also to be done. So to manage the resources properly, that's why you're maintaining buffer. It's nothing but temporary area of the memory to hold data while it is being transferred between two places. Okay, do not go that much deep into this implementation because it is taken by into the C library, right? So sending buffered output across it. So that's what it means here. So of course we'll close the buffer also. What is there in the output? Pending output angle and stream close. That's why it should close the file after you finish it. You can also explicitly request the buffer output for stream to be written out. F flash. So they will request buffer output to be written out. So buffer flow X market flash buffer underlying system. It will be directly not inside the buffer, but it will be printing the directly to the underlying host environment. Okay, it will be there in the buffer, but you have to flush pending output from its buffer to underlying host environment. Stream level. So here we are writing small code. That's why we don't understand the difference between buffer and remaining things. These of course handled properly. But if you write big codes, then we can understand it. Let's take this problem. Thousands we are putting character A. So you think might for every okay, I now get it. So 1,000 times we are looping, right? So every time I'll try to open a file and give the put the character A means how many times we have to convert the operation. So it will be 1,000 IO operation. So that is insufficient. So now what we will do? Just we will put in the buffer and store it 100 characters, and after completing this one, the line will throw entire. So you can say like after 100 puts the false. So when the what happens when now the C library can transfer the accumulated data as larger block, then so when buffer is full, it throws the values, or if the uh, time is up, you have to print inside the print file, then you have to do it. So it's implementation dependent. So this is the best example. So cost of initiating IO operations. So IO operations means input means I may have to deal with one's keyboard monitor. These are also IO, right? So accessing every time for this line of code may disturb other devices. So that is not. So that's why buffer concept is introduced here. Yeah, it is giving unnecessary big just to want to ChatGPT just want to use the tokens that much. This much information. Yeah, how much unnecessary points. Whatever there in the buffer, it will be flushed to the respective IO operation. Okay, so completed this one. So we completed 17 points. Basic file handling process. So let's see this one. So the general sequence is declare file pointer, open the file, if we check whether open is opened or not, do some read or write or mark and close the file. So that's what we saw here. So writing to a file. So first we opened a file, then what is that? Reading a file. That then we have to see functions on reading a file and writing a file. So let's start with the writing to a file. So uh, so writing to a file. Mm, so let's take a 5 minutes. Yeah, sorry for taking long break. Uh, so let's resume now. So we are in the writing of writing functions for files. So let us see. So it is 18 point, right? 18 point around. Uh, yeah, 17. Yeah, 19 point. It is writing to your file. So there are several important functions. So if you want to write a character to the file, then you have to use fputs. If it's a string oriented, so if it is fputs and formatted, so it is fprintf. So block or binary. So this is for the binary systems only. Fprint you have to use. So let's see fputc, write one character. So if we take this one, we open the file and then we saw it is equal to null. Then return one. If it is doesn't open this file, so it is open. Then we are writing a character into this stream fp. So this is the character and stream. So we have close. So another example, f put c hits comma fp. So there will, it will be coming as high here. So f put s. Now let's see throwing a string into the file. So f star fp is equal to fopen dot data dot txt w. If fp is equal to null, return one. F put s. So we are writing this whole string into the fp. So it is closed. So let's see important point. Fputs does not automatically add slash n. So the produces hello world. So we have to write to mention it slash n. Then it produces hello world. Even the put c also like that. You have to put slash n. Uh, so printf, it's a formatted output to a file. So fprintf is similar to printf. So printf, how you take a format specifier, format string, and then we give the variables, right? So these are the same. Just we have to write before stream here, file pointer. So fp comma a is equal to star d comma. So d is replaced with a. So the difference is the distinguishing. So it's a standard output, and this is a specified file stream. So int age is equal to 20. So float marks. So you don't need to write only one variable. So you can write two percentage d's and write age comma age also. So how many variables we are writing? Then we have to continue like that. How we write in the printf statement, like that only it is same. So reading from a file. So important reading something simple. Get c, get sub scanf f read. So So we saw text files reading printf, fputs, fputs, right? So now let's see reading from a file. So we have put for the writing, get for the reading. So we have to get from the file. So that's how you can remember. Let's see this all. I think we didn't see right here. Let's hope that down it will come F, right. So F gets C, read one character. So it will be just the syntax will be stream. For F puts it will be character comma string. So F gets C is only stream. So we have to take it as integer. This is something important. Even the file exists in character, but you have to take in integer because characters can implicitly converted to ASCII values. So ASCII values are nothing but integers again. So but we have a every possible character transient character value. We have this UF which is an negative value. So to catch this UF the one, so we define we take it values as integers. Every possible unsigned character value plus that special value UF. This reads the characters until the end of the string. So it's not a character stored in a file, it is a condition value recorded by input operation and no more input is available. So this is a very important concept. Let's ask the internet also. Now let's see in the Stack Overflow. So this is just an implementation. That's how they gave the definition for upget C. So I think confident. I think this is very in depth we are asking. So it's a better implementation to do integer value than character, because if 255 value is designed, then it will throw -1. To truncate the integers into signed characters, then it throws -1. So when you check C is equal to EF, so the programming mistake in the data bit, so it will think as -1 is EOF, so it will terminate early. So characters is 0 to 25, 255, then it should be given outside EOF, so that is why we give -1. So it achieves maximum efficiency because all are ones. So where this is enough, it's the implementation will accept it, that's all. EOF. So let's see what is putchar means. What is putchar function in C does? So we used to output one character screen. So adder prints one character. Okay, it takes one character and each value represent the character as it is. Or EOF or output. Okay. So integer, right? This one. So it will put char is these notations are same. So int value is changing to character. So let's go reading and enter file by character by character. So you have to use this while loop. Open the file, check it is open. If it is open, let's take the characters, put char and close the file, return 0. F gets it reads a string. So this is for writing a string into the file. We use F puts. Uh, First will be file pointer, then it will be string. Oh, no, yeah, string value and then string. Let's see the syntax of F puts. Yeah, F puts. Yeah, string value and string. Yes, F gets is uh, string size. I mean buffer size and string. It attempts to read a line of string. That is like one line. It will take and print up. So it returns string. So you can see percentages str. So it will be taking a string. So size of 100 it will take and it will print. Let's ask how exactly F gets work. See, store including /0. Hello world is there. So it will take hello. So 10 I said. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I think two spaces are there here. So 10. So after R it will be 9. So 10 is 0. So it shows because it has these limits. So now we'll print. STRN means channel input, which is keyboard. Uh, so this is what we saw gets in string. So we use this for pointer set. So we can take for the string. So the difference is that you can take spaces, not the slash n, but you can take the spaces. Let's see. Let's revise our concept strings. Yeah, it can read spaces, can be stored as string. This is complement span. So it will return a pointer points to this slash n the first occurrence. So it will be 0. So here object points to the file object, so it will taking the file. Okay, so now let's see scanf. So scanf format input while from a file. So let's see the code reading the file. Scanf is similar to scanf only. So we will be writing file pointer stream and the exact scanf copy. So the f printf is the same. We'll be giving file pointer, format specifier, and the variables. So int a comma c we have 20, so we'll be taking this value. Think standard output prints to the monitor. This one prints to the file pointer. So scanf of the same reads the standard input from our keyboard. It takes from file pointer. Standard streams. So let us see standard streams here. So stdin means keyboard, std out means terminal screen, and the std error stream means it will print to terminal error screen. Let's see somewhat deep. What is std error? So it is nothing but output error message and diagnostic logic logs. So it is completely independent of std output, ensuring that the critical error messages remain visible to the user even if the primary program data is redirected or sent to another page. So we'll not go standard error that much. We'll not be using relationship with file functions. So printf can be thought of writing to standard output. Scanf it is standard input. So therefore is nothing but we write in this stream. If we go to stdout, it is a printf only. stdn it will be scanf. So that is the meaning here. So putchar is nothing but put c. So character to the standard output. Getchar is equal to fget c stdn. So yes, so that means we'll be getting files to the terminal. Yeah. So getchar means getting from keyboard to the uh, to the system. So std we should use, or you can say whenever a page is coming, you can put std out. And if g is coming, stdn. Puts and puts plus new line behavior. As it can puts here, let's see what does puts function do. Yeah, right. So yes, now so this is a writing function, not a reading function. So now let's see writing blocks of data. So what does it mean? So this is important for binary files. So pointer, size, count, and string. Pointer, size, count, and string. So what does it mean? So let's see int x is equal to 100. So first one is ptr. So ampersand address operator will make this as a pointer. So now it has the address. So size of the x, so size and count 1 and the stream fp. So now let's see what happens. Address of data, size of the each item, number of times, destination, stream. So one int object is written. I didn't get the count, but let's see. Hmm, let's see the puts function. So followed automatically by a slash new and print a string to the screen. Putchar prints one character. It prints one string plus new line. So it automatically goes into a new line. So print a formatted output for many outputs. So this is equal to this one. Okay, now let's see apply. So apply is a C standard library function to write a block of data from memory into a file. So number of items to write. So address of the data in memory to be written, size of one item in bytes. So number of items to write, file pointer of the file. So let us see. Go to the memory address of X, take one item where each item is size of X bytes and write into the file pointed by FP. Okay, so I'll take one time of this size and print. Now say if I say 5 times, then you have to again each item is 4, so 5 into 4 20. So you'll be getting 10, 20, 30, 40, 50. Number of items successfully written, not the number of bytes. So it gives 5. Okay, it gives the integer value. Okay, so fread is completed and fread reading blocks of data. So it will be read. It is also so it is also pointer size count string. So you will be giving that much value to the x. So read and write examples. So pointer size uh, count and string. Yes, sorry to put you in wait. So let's now see our reading. You will be giving the value to x. Okay, so understanding read and write. So this is what we learned. So return value of read and write. Oh, this one also gives. So both return size t, which the returns value, the number of items X could read or written. So how many times? So read and write returns size t. Uh, F open returns file pointer. F F open returns file pointer. Next one we read F close read. F close what F close returns what close returns in C. I think it's a void. An integer indicating the outcome of this. So 0 means close. EOF error. So it is also integer. So F close an integer. Mm, F open, F close we saw, and then what we saw, F reading part we saw. Sorry, writing the function. So we saw for writing F mm, yeah F puts so F puts put C. So yeah, it let's see what is F puts written in C. Integer only. So puts written. So I think puts also integer only. The printf also returns integer only. And the printf also returns integer only. No, it returns total number, yeah, which is nothing but integer. And let's see now for the fgets. So fgets returns string pointer to character array, and fgets returns integer, and f scanf returns integer, Yeah, integer, number of items successfully matched and assigned to variable. So it returns one for the IO if end of the file. Failure happens, it returns 0. If EOF, it will print -1. That's so F read and write also returns number of items successful read or written. So it doesn't mean objects, it means objects. It means objects, not bytes. So file position indicator. So now let us see 30th point. A stream maintains a file position indicator. So it is like pointing to corresponding character in a file. So get C. So we'll be taking the file and putting into the monitor. So hello position after it. Okay. So after reading one get C, it will be moving. So this position is important for sequential random file access. So FTEL. So this tells the current position. So which give long. Long means it is also integer, but its range differs. It is bigger than integer, so it reports the current file position in terms appropriate to the stream. So it reports the current file location in terms of appropriate to stream. So let us see this one. So it is 1. So it is at the age. If I don't do anything, it will be showing 0. So that is what tells F tells. So it returns index current file position. So it is nothing but integer. So fseek move file position. So ftel tells the position. Fseek will move the file position. So let us see fseek also. So fseek file. So syntax is file uh, pointer and long offset int origin. So let's see the origins can be seek set, seek current, seek end. So seek set means beginning, seek current means current position, seek end means end. So if we say long offset 0 comma 6, it moves to the beginning. Uh, it moves to the end. It moves to the according to the stream position rules from the beginning. So let us take this one and uh, let us see what happens. 6. So 6 means what? Into ch is equal to will take. Let's print. Let's printf. F for scanf, sorry, scanf. So scanf for printf, we have to use writing is prime, yeah. So scanf, so, sp, comma, just normally we use bookcat, bookcat ch. So now let us see what it prints. It is printing, that's right, some 10. So this is the m, yeah. So it's 1 0 1 2 3 4 5 6 7 7. New line means 8. This is 9. So that's how I guess printing. So let us see. Long offset. Let us take this and go deep inside. By 5 bytes from the beginning of the file. So measure the offset from the beginning of the file. So suppose the file ABCDF. So byte will be 0, 1, 2, 3. So character is 1 byte. So suppose the file is positioned at here. So 5. The position becomes 1, 0, 1, 1, 2, 3, 4, 5. It will be 5. So new file version is reference position plus offset. Yeah. So now let us see fseek also we saw. Now let us see. So fseek syntax is write a file pointer and offset and then the position, the origin. So rewind, it moves the file position to the beginning of the stream and creates the stream server and the UF indicators. So it is like going back to the stream, beginning of the stream. So sequentially versus random access. Now let us see sequential access versus random access. So F get C. So it's getting file. So F get C, it will print 1, then 2, then 3. So move directly to another location. What happened? Maybe this because of this one. So sorry, gets right or gets, yeah. So FPO, the end of file indicator. So if you want to random access list, after writing to, you can change the pointer position. You can take the FTL and write a offset. I want so it will throw a position, right? So from that you can add the offset by passing to the F6. So let us do like that. So now we'll do F6. Okay, FP is the pointer, and let's give the offset as 5, and then we'll give FTEL of FP here, and let's print up now LD comma LD comma FTEL of FP. Now let's see. You can see that too, and it went to let's put some slash in here. Now let's run to AG print. So 2 from where it is printing to put here AG. Okay. So okay, so it is being 56. Okay, 5 bytes. So it's pointing at 56. Let's give 1 byte. Now let's see. Yeah. Hmm. Let's do the put here. Now let us see what is happening. It is out of the range. That's why it is doing that one. So FAO it means end of file indicator. So checks whether the team EOF the file pointer reaches. So you can write gets the mm, printing the character, or you can write f gets c is not equal to UOF also. So this is generally option for reading. Uh, Why UOF detected by the input operations. So the correct logic is attempt read, did read success, yes, process data, no. Detect, de- detected by input operations. By input operations. So I don't know what is it means, but maybe this is long enough to do. This is easy. Let's this one is, or let us see. We have a few. go past the variable. So let us read once again. I didn't get the point here. Return non-zero if the stream send of file of indicator has been set. It comes to only after read operation attempts to go past the available data. ABC, gets C, okay. Let's ask what does it mean? What does it mean? It means file object internally keeps a flag indicator that records a read operation has reached the end file. So, if the end indicator is not there, then it can't read. So that is what it is telling. Let's see what will happen if you write this one. Okay, so it is checking the EOF, so it can't read this one. That's why it is printing some. Now I got it. Um, so now let's go. F error. So we don't need to write printf. We can use F error also. Indicator is set. So if the loop ended because of EOF, error is false. If it ended because of an input error, can indicate that. So if it is ended with EOF, so this will be false. So it will not go in. So if it is true, then we can print out this one. Clear error. So it clears the EOF and error indicators for the stream. So this can be used when you want to continue using a stream after handling an error condition. So after handling an error condition, you can remove that error indicator flag to false, and then you can use that same file pointer. So file rename. So we saw F error and clear error. So file rename. So renaming the file, old name and new name. So old name will give data text and data to dot text 3 times. So let us see if this online compiler can do. No, it is even new file actually. This is a compiler, right? Online compiler, so that's why it is giving. So So remove we can add here. Let's add a remove. Error.txt. Then it is not remaining, but it will work in normal uh, in our systems. So P error we saw F error, right? So any error it indicates, if you check the error indicator is on, then it will print up. Now we are printing the error. So here F open. So it prints an implementation environment dependent method is given the most relevant error for the example. For example, so we can use for this one. Let's not go into that much deep. Error no. So we have to include this hash file. So certain library or system can set the error no to indicate an error condition. Okay, let us see what it gives. So it is giving error number 2. Okay, so it's a keyword. So indicate an error condition. So here displays related environment error, and this one prints number. So buffering file IO input output is often buffered instead of immediately sending this already. Have to flash. This also says whatever in the output to just directly print underlying host environment. So not general save everything to physical disk immediately guarantee. Deals with the C buffer output. Actual durability and storage involves lower operating systems and mechanisms. F close. F flush is the stream here. Pointer we give. So you see here F close, and these are all F error, error number. These are all are. We're not going that much deep because these are not that much important. So when you close F buffer, all the output will be going into the stream is closed. So text file example, complete program. Let's see this one. Now let's run. To get it created. This is let's try the yeah, it's giving no file such. Now let's write a print of writes to the file. Yeah, it is completed. Reading the same file. Okay, let us see this one. What does it mean? So this is okay. This is another function to read the file. can use now this one. That is reading from this file, so it is using gets fgets. So fgets, what is the string? The I mean this is a buffer and the size of the buffer, and then fp stream. Copying one file to into another. So this is a classic file handling problem. Yes. So we have to one file data into another file. So it is nothing but copying. So how do we do? So let's open our source file and the destination file. Once if it is opened, what you have to do is take every character from the source and write it into the destination file and close both files. So text oriented, you can write so fread syntax, let's revise syntax. Fread is uh, pointer and comma, size of that pointer and comma, number of items count, comma, and our string. So let's take that is what fread is now. Uh, yeah, size of one item. Yeah. Important difference of getC and of read. Here getC is one character at a time it will take from the file, and of read also reads from one character from the file and assign it to X. So this one we are taking and we are writing into that file. Writing raw structures using Freight is not actually portable file form. Why? Structures can contain padding bytes, implementation dependent, etc. etc. So this size is we are reading, right? So I mean we are writing into it. So now let's write whole this. Now this one, right? We have to take. So now let's write this into student file. So file f star fp is equal to f open student dot txt as we are doing writing plus read. So let's write write plus. So we are writing into the student file. So this is a binary file. Has become a binary file. So separate deals with binary rates. Right. And freed will read. Let's see, freed how it reads. Let's see. Let's put S1 here. Uh, Now let's print this value. Okay. So now see what will happen. It is giving, but still this is not a good portable file format because structures can contain like this padding bytes extra. So implementation dependent. So this is we have to be remember. File pointer versus memory pointer. So this one is pointed to file. This is pointed to int. This is int object in memory. This is a file stream object. Okay. Now file is not the same as file. Don't confuse physical file. It is file object because this C stream through which your program access the file. What happens during open? So it will open the file and independent. But so C standard to especially the pair of the C stream interface, not a single universal internal implementation. File positioning and reading. So it gives a connection. Okay, so the establishment happens on open. History point we already saw. Important return values. F open returns file star. Null means failure. F close returns integer. Zero means success. UO means failure. F gets C returns integer, so EOF means end of the file. F gets it's a character star character array. F read contains size T. F read and F write returns size T, and F seek returns 0 if success and non-zero if failure. F tell also same. It returns position or else -1. L. So EOF versus null. So EOF is a special integer return value when it indicates we have reached the end of the file, and null means pointer related things. So it represents to some specific value. It represents nothing is available. Uh, yeah, this is a common mistake we already saw. Common mistake forgetting to check have open. You have to see if it is failing or not. Common mistakes forgetting F close. If we don't do, we have to write F close. When you want to preserve data, so when you want to only read the data, we use only R. So don't write. This also we saw. It is giving some after EOF. It is giving the value. We can use these both. F gets. So it will be giving F gets will be giving pointer character array. Pointer also you can say. If it is null, then it is the end of the line. So text mode versus binary mode. B represents the binary mode. On some system, particular systems where text mode may perform implementation dependent transition, but is new handling. We already saw this one. This for the gate overwriting. So file as a stream. So based on streams, so std std out, std error, so file streams. function stick file star rather than file object in everyday file system. File pointer we use. Standard of input and output files are conducted by the same abstractions. Get C. Use standard input, then it will be taking the values from keyboard. If this is a pointer, then it will be taking from file stream. So different streams. So put char and get char. So get char takes from the keyboard. It is used in the file pointer. It will be taking put char means printing to the monitor. So that is conceptually a put C is a comma standard output. So put char is equal to f put C and get char is equal to get C standard input. Got it? So puts and outputs. So puts is writing to standard input output. If we replace with the P with the standard output, then it is both are same. So it does not add a new line. Okay, both are not same. It writes a new line after putting allow. It will be printing new line, but outputs will not add a new line. You have to write new line. So we saw F and their versions. So for keyboard it is there put char. Get char we have keyboard and put char is a monitor std out. So outputs we have to specifically what is the stream. So both are same, but S when it comes to S part, these are not both same. This prints a new line, but this not prints new line. Random access example. From the position. So F6 important get point. Do not blindly assume that so that's why our before we saw it is 56. So this is for portable as addition restrictions. Rewind goes to the beginning, and equivalent positioning will be 0 F6. So it's a shortcut. Not only it's a shortcut, one of the point is shortcut. Appending. We already saw update. We can R plus W plus A plus. Important update to stream rule. When using an updated mode such as R plus W plus A plus, you must follow the stream rules when switching between reading and writing. In particular, when switching from writing to reading and an intervening position operation that is F flush. So after you read, right, before writing you have to do the f flush. So that's what they are telling. So example of read mode. So open have scanner, printf. Scanf means we have to read from file and print it to the respective value. As to printf means take the value. Printf is writing mode, right? So we will take the value from here and print to FP. So complete stream rules should be maintained. So we have to write flush because the buffer may not be completed. It is going to writing mode. So that is why file descriptor versus file star. So this is something another POSIX low level. We don't need this one. File descriptor. I don't know what is this. What is it mean? But I don't want to go that much deep. Search for it. Portable operating system interface standard for direct interaction with the operating system kernel. Okay, so portable operating system for direct interaction with the operating system kernel. So let's not go into that much deep into it. Program standard input output, WebStar, C library, OS interface, file system, physical storage. So first it will be standard input output and then file star, then library system, then OS and then file system and physical storage. So complete function map, open, F close, character input or output, F get C, F put C, input output. So get C writes FP takes from file and prints into the system. It takes from file, puts C, puts into the file. F read, F write, F seek, F tell, rewind, status or error. So we all saw this one. That much not important. This in buffering, F flush, rename and remove. So right, uh, we wrote right into the file allow 10 and read. We are reading the file and then line by line. This is a character by character. This is the line by line. Second is this one. Gets so binary right and that size of x1 x3. So this is the x variable size of x. So this many One we will write to the file. From file we will read this one. When go back to position will be go back to the starting of the file. Position this will be going to the M. So find position. So long position is equal to capital P. So it will give the position now where the current file is giving C stream object. So I think we have to learn about C stream, I guess. Okay, now we don't go that much deep. It is just a connection between this program and the destination. So triggers plus means update POF matrix get C return sync. Yeah, this is just a revision. Let's take these notes and print in our, add it in our notes. Maybe I think I have added new document tabs for each thing I do. Do now. So we have completed C. There is only handwritten notebook is completed. So now we will read the main textbook. So I will be not reading whole day the textbook because can read boards after reading your own notebook. So I will be taking. I will be moving to another subject. So I will be I'll be read. I'll take another subject and I will read per day 3 hours and then I will read 2 hours for C and then I will practice some problems on C. So mainly I will be solving gate problems. So So let's replace gate with competitive terms. Or tabs. Yeah. Now grade is replaced with high value competitive exam points. So this is what I think have to like this write inside a tab each. So I wrote like a heading. So this is somewhat backslash. Now I have to retype the work. So from the next lives, I will be reading C textbook. Uh, what I forgot the textbook name also. So like 7 days, 7 sessions. Took. So it is C programming language, second edition by W. Kernighan and Dennis and Ritchie. And I will go to the next subject. I'm thinking of going to digital logic for now and also practice some problems in C. So for competitive exams, especially in India, after graduation, for post graduation, you want to go, you can write a GATE exam or UGC exam. So mainly I will be going with GATE exam, not with the UGC exam. So let me gather the resources to continue this live session. So for now, the live is ended. Thank you very much. We will be going through these notes once again also. We will be adjusting these notes into tabs. Each topic one tab, each chapter one tab. Okay. Thank you. Uh, you if you are new to this channel, please check the channel, and if you feel something is useful, please subscribe to my channel, and please like the video also. Thank you.